All right. So there's a common practice to refer to exponents as powers or powers as exponents. If I say something like 2 to the third, okay, that is equal to 8, right? Okay. We refer to 8 as a power of 2. Okay. So the whole like 2/3 thing, the entire symbol, we usually refer to as a power. This here, this number, that is what we call the exponent, right? Okay. If you want to, I do this, it's unintentional, but sometimes I will call the exponent a power. Sometimes I call it power and exponent, okay? If you do that, it's not going to get you in any trouble with your vocabulary, okay? So we're talking about powers and exponents and that kind of stuff. We're referring to something that is exponential, okay? Remember what exponents mean. Like if I have 2 to the third, that means repeated or repetitive multiplication. So 2 to the third means 2 times 2 times 2, correct? Okay. 3 to the fifth means 3 times 3 times 3 times 3 times 3. So in this case, right now, I've got 4 to the third times 4 to the fifth. What does 4 to the third mean? Okay, so 4 to the third means 4 times 4 times 4, right? What does 4 to the fifth mean? Okay. So try to color code it that way. We get that, but there is a multiplication right here in the middle that should go right there, correct? That kind of makes sense? So how many 4s am I really multiplying together when I say 4 cubed times 4 to the fifth? 8. Okay. So this here would mean 4 to the 8th, right? How can I go from this here straight to that? Lindsay? 5 plus, so I add the exponents, right? Okay. Now, that is only if the bases are the same, if they're all 4s, right? Okay, so if it was like 2 to the third times 4 to the fifth, you can't do this, okay? But if they're the same base, and this is what this rule down here at the bottom says, if you have the same base, so in this case A, and you have exponents that are integers, meaning that they are positive or negative whole numbers, then your result is going to be whatever that base is, raised to the m plus n. So that's showing that all we did above in the 4 to the third times 4 to the fifth to get to 4 to the 8th is we took 3 plus 5 and got that 8. Does that make sense to everybody? So it says usually the common phrase is that when you multiply like bases, you add the exponents. Multiply like bases, you add the exponents. That's a common rule that you will use endlessly throughout Algebra 1, Algebra 2, and so forth. Okay? So some examples of this real quick. If I want to take like x to the fourth times x to the third, what would you call that? What's that going to turn into? X to the seventh. So usually this is the way you see it written sometimes, like in a note, in a textbook or something like that. They'll say, oh, we're going to take the 4 and the 3 add them together, but we know those are like terms, so we get x to the seventh. If we go 2 to the second times 2 to the third, what's that going to give me? 2 to the fifth. Okay. If we go 2 to the negative third times 2 to the seventh. 2 to the fourth. Okay. It doesn't matter. It doesn't matter if your exponents are positive or negative. You're going to add them. Okay. Just be careful. Sometimes they'll give us ones like this where let's use a different base. Let's use 3. So 3 to the negative fifth times 3 to the negative second. What's that going to give me? 3 to the negative seventh. Now, do I like negative exponents?
No.
No, so we'll never leave our answer this way. We will rewrite this. Remember, that's over 1, right? So I'm going to rewrite this as, this 3 to the negative 7th is going to go where over here in the second fraction? Should go to the top or should go to the bottom? The bottom. And then it is left with a 1 there, right? Okay. So if I'm ever stuck or confused or worried that I've done something right or wrong, we should be able to go to Desmos, type in 3 to the negative 5 times 3 to the negative 2. Gives me that number right there. Pretty nasty number. Gives you see there, we're putting in scientific notation, right? So there's kind of a link to what we're talking about in the last section. If I type in 1 divided by 3 to the 7th, does it give me the same number? So that tells me that and that, though they're two different formats, they are the same number. Okay? We cool with this? Okay, multiplying like bases, you add the numerator. So, just real quick, this one here is not very difficult, but really what is going on is there are numbers out in front as well. There's coefficients out here that we're actually multiplying to, or as well. So 1 times 1 gives me 1, right? But now when I multiply the bases of n to the negative 4th and n to the 7th, that's going to give me 1 n to the what? N to the 3rd. Okay. Now, the reason I said something like, the reason I put those 1s there to see that we are multiplying those coefficients is because in the next problem, they're no longer 1s. Okay. Think about this. If I look at this next example, you have a number 4. You have a number z to the 5th. We just don't know what z is. So, you know, if z were 2, that number would be 32. If z was 1, that number would be 1. If z was 3, that number would be 81 to 43. Okay? We just don't know how much that is yet. We've got 9. And then I've got z to the negative 12th, which is, when I know what z is, it's going to be a pretty nasty looking number, but it's a number, right? So we have 4 numbers being multiplied together. If I were to give you something like this, let's just go back to, I don't know what grade, 6th, 7th grade. If I would have 2 times 3/4 times 5 times 4 thirds. If I ask you to multiply those 4 numbers together, which ones would you focus on first? Which ones would you actually multiply together first? 2 and 5. Because they're similar types of numbers, right? They are whole numbers in this case. So you would have learned at that stage that you can actually move the 5 and move the 3/4 and rewrite it that way, right? You guys remember what property allows you to move things around in multiplication? Say again? Commutative. Okay? So we'd move those around, and then we would display that we're going to group these two, and then eventually group those two. And let's just kind of talk about why this would be an easy or an easier way of multiplying this set of 4 numbers. What's 2 times 5? 10. That's easy multiplication, right? What's 3/4 times 4 thirds? 1. Okay? They're reciprocals, right? So you see how grouping those with the associative property, moving with the commutative, and then grouping with the associative makes multiplication easier, right? Okay? I could have taken 2 times 3/4 and got 6/4, and then 5 times 4 thirds and got 20 thirds, and then figured out that, well, 6/4 plus 20 thirds is exactly the same thing as 10 through some other processes, and count down that kind of stuff. But reorganizing and grouping things that are similar in their structure is a good idea. So let's look down here at the actual problem that we're working on. Which of those numbers are similar in their structure? 4 and 9. So I'm going to move those and group those. Good. And that's going to leave the z to the 5th and z to the negative 12th to actually be grouped as well, right? So we grouped the 4 and the 9 because you guys saw that's going to give me 36. But by doing that, it automatically groups the other two terms that are of the same structure, z, right? Z to the 5th and z to the negative 12th. So what do I do with those? How do I rewrite those? I'm going to add the exponents, right? And it's negative 7, yes? Okay. Do we leave our answers with negative exponents? I would think, guys, if they gave you this question in your homework this evening, if you type in 36z to the negative 7th, they're going to give you an answer say wrong, but in that feedback box, it's going to say this is a equivalent amount, an equivalent solution, but it's in the wrong format. We don't want negative exponents. So if this was over 1, that 36 is going to stay, right? It's got a positive exponent. Where is that z to the negative 7th going to be? In the bottom. And it becomes positive 7, right? So we're going to end up with that as an equivalent form of 4z to the 5th, 9z to the negative 12th. Okay? Now, just in terms of structure, in, let's just say, complexity, how confusing something looks. Would you agree that compared to that, one of them is a little bit cleaner looking, a little bit less confusing looking? Less objects, right? In the bottom one, the one circle, there's only 2 terms, right? In the top one, there's 4 terms, okay? We like to simplify and want things to be less complex, okay? Now, again, we can check this. And I hope, going through these processes that you guys are seeing the benefit of checking them, okay? 4z to the 5th times 9z times 9z to the negative 12th. Hit enter. It doesn't know what z is yet, so that's why we got the warning sign over here. And we'll have 36 divided by z to the 7th. Okay? What do you want z to be? Give me a number. Heard 4. If I put 4 and it gives me that, are those two things the same? These two numbers the same? Yeah. And if I put it as a fraction, we see it maybe a little bit easier. Kaylee said 6. So plug in 6. Are those two numbers the same? Yeah. Okay. Again, if you want to put it as a fraction, okay. So we kind of based on the size of this number, kind of create an issue for Desmos and change it to a fraction for us. But regardless, we see in scientific notation that they are the same. So my hope is that you're using Desmos. So on a test or a quiz or even homework, you should know before you go on to the next question whether the one that you have chosen, the one that you've typed in, is correct or not, right? And that's my hope, is that we realize that, and that everything that I've given you so far this year, there has been some type of check that we can use to provide ourselves with maybe a little bit of confidence in knowing what we've done. And I hope that there's not a single one of us in here that checks it, finds out that they're wrong, and still submits it and goes to the next question. Okay? So you find out that you're wrong, you can take the steps to fix that error. So what happens is it doesn't matter, guys, how many things we're multiplying together. We multiply 2 things, 3 things, or 30 things. It doesn't matter. So in this case, what numbers work the best together? Okay, 3 and 9. I heard 3 and 2, and I'm going to put those together and say 2, 9, and 3 work the best, don't they? Could I rewrite this as 2 times 9 times 3, and then a times b to the 4th times a squared? Does that make sense? And because it's multiplication, all of them are stuck together with multiplication. Okay, and that's the key here. We can jockey anything around that we want to because multiplication is commutative. Okay. Now we'll take 2 times 9. What's 2 times 9? 18. Now we'll take 18 and multiply it by 3. What's 18 times 3?
48.
Close. 54. Okay. And so I see 2 times 9 is 18. 18 times 3 is 54. Could I have gone 3 times 9 and got 27? And then 27 times 2, that might be a little bit, you might be able to see it. That's 54 a little bit easier. Okay. A commutative property again with multiplication. Doesn't matter the order that you multiply. Now we're going to go over to this stuff over here. And what is the exponent for this first A? 1. So if I got that A and I've got that A, they're like bases, right? So I can rewrite that as A to the third. And B, nothing to multiply B to the fourth with. There's no other bases of B. So it just stays B to the fourth. That's my answer. What's the issue? Sure? All right. Here's a situation if I want to check myself. 2A, 9. I don't know why it keeps putting that down there. 9B to the fourth, and then times 3A squared. And then I got 54A to the third, B to the fourth. The only thing in this situation when I check this, I've got multiple variables, right? So give me a number for A. I heard 2 first. What do you want for B then? When Desmos substitutes those in there, and we're using the technology to hopefully do this for us, but you could do this without Desmos' substitution process. You could choose an A value, choose a B value, plug them into both, and evaluate kind of longhand. But you should get the same result both ways. Here we get 1,037,232 for both of them. Okay. The one thing that you're going to recognize is because when we look at things that are exponents, it's repeated multiplication. Those products become very large very quick. And what I mean by that, if you were to give me like a number like 17 is a relatively small number compared to what we really could choose. If I put 17 in there, you see how big that value gets. Okay, 170 compared to all the numbers that we know, 170 is a pretty small number. If I plug 170 in, because eventually I'm taking 170 and I'm multiplying by itself 4 times, I get this number that's 11 decimal places. I got to move that decimal 11 spaces to the right to get that full number. Does that make sense? The standard number. So when I do substitution, what I like to do, so I like to stay close to those. I like to stay, my values I choose are like 1, 2, and 3. Try not to repeat. So if A is 1, I don't like to use B as 1. It's really not an issue, but I don't like to do it. But you see there, A64 equals A64, so they're right. Is that okay with everybody? I'm going to put 3 of these up here. I want you guys to work. You can work with one another. Can you guys all see? That's kind of doesn't zoom real nice. Is it okay? Is it okay that way? You guys all see those? I guess there's 4 there. Let's see what you come up with those for. I'll give you, I don't know, let's go 6 minutes here and see what we can come up with those. All right, so should we have the first one done, right? All right, so what did you get?
12 y to the 7th, z to the 3rd.
Good. 12 y to the 7th, z to the 3rd. So you took the 3 and the 4, multiplied those, and got your 12, right? Yeah. You saw that this y and that y they're like bases, so you took that 3 and that 4, add them together, get that 7, right? What's the exponent for this z? 1. Okay? So you took that z to the first and that z squared, add the 2 and the 1 together, you get z cubed, right?
Wait. What was the last part again? How do you get
So z's are the same base, right?
Yeah.
So we take that 1 and that 2 and add those together, and it gives us our exponent for z to the third. Okay. Look at number 2. What's the coefficient that you're going to get? The number up front, 15. So you got the 5 and the 3. What I do, guys, is I always go through and just always look for coefficients, because those are all going to be things that work together real nice. They're real numbers. So a real number times a real number gives you a real number. So I go through and I find all of those. And so I got a 1 in front of the AB squared. I got a 5 in front of the A squared B cubed. And I got a 3 in front of the A cubed. So I go 1 times 5 times 3, it gives me 15, right? Then I'm going to go systematically through and look at, okay, there's an A. Are there any other A's throughout here?
Yeah, at the end.
Okay.
Oh.
So there's one there, so it's A to the 6th. Okay? So that's just adding that 1, that 2, and that 3. So now I'm done with all the A's, right? Now you don't have to do this, but you could just say, okay, done with that A, already used it. Done with that A, already used it. Done with that 5, already used it. Done with this 3, already used it. Done with that A, already used it, right? What is left then? B, and it's going to be to the 5th. And that will systematically kind of wipe away the things that I've used and things that I need to address. If I wipe away the B squared, B to the cube, there's nothing left, right? If there was a C or a D or something else, I would then continue with the process. Okay? So we go to the third one. Okay, so the numbers that we'll multiply together, Jaden? Oh, yeah, the ones that I wiped away. Oh. That one. So it's 15, A to the 6th. Thank you. When we go through on the third one, yeah, so, sorry. So yeah, so there's a negative 1 there, right? In front of that A. And that's the one that people struggle with. Remember, if it's a negative and then a variable, there's a coefficient of a 1 there. So I'm going to go through and I'm going to take the 5 times the negative 3 times the negative 1, right? So what's that give me? Positive 15. Positive 15. All right, so now, let's go. So B to the 4th. Are there any other B's in here? B to the 1st. How many B's will that be? Okay, so B to the 5th. Okay, so wiped away, wipe that away. Those are gone, all right? So now the only thing that's left is A, right? So I'm at this point here, A squared. Are there any other A's?
Yeah.
A to the 3rd, right? What do I do with those? Add them. That's always what I do. Okay.
Wait, hold on. Okay. Oh, okay.
What if I do this? What if we go, let's do this extra one here real quick. Let's go 3A to the negative 7th B squared times 4A to the 3rd B to the negative 6th. Okay. So what coefficients are you going to multiply together? 3 and 4, so it gives you 12, right? Okay. Okay, so what's that going to give me? Negative 4. And now I'm going to look at the B squared and the B to the negative 6, right? What's that going to give me? Negative 4. Now, do I like to leave my answers with negative exponents? No. So where does the 12 go? Does that go on the top or the bottom? What's the exponent for 12 right now? 1. So it's a positive exponent, right? So it stays put.
So if it's a negative exponent, it goes to the bottom.
So A is going to go to the bottom. B is going to go to the bottom.
So if it has negative exponent, it goes to the bottom.
Yep. Unless, so let's do another one, because that's a good question. So if I have like A cubed B to the negative third over C to the negative fifth, let's go A, and then let's go B over C squared. Okay. So this looks a lot more complex, but it's no different, okay? It's fraction times a fraction. When you multiply fractions, it's just straight across numerator times numerator, denominator times denominator, right? Okay? So when I multiply the numerator, so I'm just going to look at the numerators by themselves. So I like to, when I see fraction multiplication, just draw my attention to that stuff first. So if I rewrite my A's, it's going to be A to the what? A to the fourth. Okay? If I do my B's are going to be negative second. Because that's B to the first, right? So negative 3 plus 1 is going to be negative 2. Now I'm going to do the bottom. C to the what? C to the negative third. Okay? Now, we don't like negatives, right? So A to the fourth, is that positive? So it stays put, right? B to the negative 2 goes to the bottom. Now C to the negative 3, because it starts negative in the bottom, it's going to move to the top and become positive. So wherever they are negative, they are going to switch to the opposite side of the division sign. Okay. Okay, so how does this tie into what we talked about on Friday? What?
We learned scientific notation.
You really gotta go over. Okay, I'm good. What?
So you made me zoom all the way over, and then.
I just need a B2.
Okay.
I forgot what it was. I started saying
Where are you, Dory?
Yes.
All right. Dory did talk a lot, didn't she?
Yes.
In circles.
Dory.
Finding Nemo.
Dory's not
Blue.
alive. No, it's not.
All right, here we go.
She just said Dory the guy fish.
All right. So if I look at 3 times 10 to the 5th and 5 times 10 to the negative 12, are these two numbers being multiplied together?
Yeah.
Is this notation for two numbers being multiplied together? Is this notation for those two sets of parentheses being multiplied together? So we've got 4 numbers here being multiplied together, right? Okay. So I don't think people are going to like to multiply this.
Sounds like Mr. Miller for a
Well, some of us hit puberty later than others. All right, so that number there in standard notation is 3,000. This number here in standard notation is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros followed by a 5. That's what that negative 12 means, right? If I ask you to multiply those two numbers together, we're going to struggle with that. The process for doing this from like 3rd grade where we learn how to stack numbers and multiply them is nasty, okay? But if I put them both in scientific notation and realize that it's simply 4 numbers, that one times that one times that one times that one, can't I, because it's all multiplication, take the 3 and the 5 and pair them, and the 10 to the 5th into the 10 to the negative 12 and pair them? Does that make sense? Group them in a convenient way. Group them so that they are working with numbers that they are like. So 3 and 5, they are real numbers. They are easy to multiply, right? What's 3 times 5? 15. Okay. Now, times 10 to the 5th times 10 to the negative 12. Is that base there and that base there the same? So can I write this as times 10 to the What do we do with those exponents? Add them, so it gives me negative 7. So can I rewrite, if I'm going to go scientific notation, is this 15 times 10 to the negative 7? Does anybody remember, though, and this isn't, like, I'm not trying to be like a stickler for rules and stuff like that with this, because if we were doing like a hand, paper and pen test or quiz, or if you're using this in a science class, 15 times 10 to the negative 7 is fully, it's 100% acceptable. But the way our text and Math Excel and then of course the exam is designed is that they abide by the definition of standard notation, where that highlighted number is got to be between 1 and 10. Okay? Right now it's outside that, right? So where's my decimal is after that 5. It's to the right of that 5, right? So I need to move it 1 to the left, correct? Okay, so... Oh. So I'm going to move that one spot to the left, and it's going to be 1.5 times 10. Now, when I moved it to the left, okay, what do I need to do with this exponent? What's that exponent going to become? Negative 6. Okay? When you move your decimal to the left, your power of 10 is going to, you're going to add 1 to it. Does that make sense? Or add how many spots that you moved. Okay? If you were questioning whether you did that right. Yes. So if you're questioning whether you did that right, you have a great tool here that will help. Okay? If I want 15 times 10 to the negative 7th, Desmos will automatically change that to scientific notation for you, abiding by the rule that we have defined with scientific notation. Okay? So that's a nice thing. All right, so let's look at these two. Okay, if I ask you to take 2.3 times 10 to the 8th, so that is, let's working on our scientific notation, that's a 2, a 3, and then how many zeros? 7. Because that accounts for the 1 that is part of that, right? So 7 zeros. Times then 4 times 10 to the 7th, so that's actually going to be 40 million. Okay? Now this number is this is 230 million. So I'm asking you to take 230 million times 40 million and give me a result. That is an ugly thing to do, right? Okay? Let's just look at the idea that is designed with this process that says you can take, because of the commutative property and associative property of multiplication, you can take that number times that number. Okay? Now, some people don't like this because 2.3 times 4. Okay? I'm going to do 23 times 4. What's 3 times 4 real quick? 12, so carry my 1, right? So I'm going to put a 2 down, or carry my 1. What's 4 times 2? 8 plus 1 is 9. Okay? Now that was 23 times 4. And when I did 23 times 4, I had to move my decimal spot 1 to the right, correct? Well, let's move it 1 back to the left. Let's get it back to 2.3 times 4. So 9.2 is 2.3 times 4. Okay? Now it's going to be times 10 to the what? Hello? Yes. Okay, thank you. Yep. Bye. Bye, Lindsay. So it's 10 to the 15th. Okay? So that number, better written, 9.2 times 10 to the 15th. Okay? Is that number between 1 and 10? So we're done. We leave it this way. Okay? That would be a 9, a 2, and then 14 zeros, right? So pretty large number. 9 zeros is a billion, right? 12 zeros is a trillion. 15 would be a quadrillion. Okay? Like you are like.
What's a gazillion?
I don't think that exists. God's not a.
Let's say it's 20 gazillion.
Okay. So let's do this one. Now here, this you might want to maybe take your calculator because of the 3.4, 5.6. If you want to go 34 times, if you know what 34 times 56 is in your head,
I do.
and then move the decimal place 2 spots after you do that product, you can. But if I take 3.4, let's see here.
5.6.
So 3.4 times 5.6 gives me that number right there, right? Now I'm going to take 34 times 56 just to prove a point here. Should give you 1904. Does that make sense? But because there are two decimal places in the first number, I'm just going to move that from the 1904 and move the decimal spot 24. So we have 1904.
Does it really matter? Like, can you multiply the decimals and the whole numbers? No, I mean like, okay. Does it matter if you multiply decimal and decimal, or do you have to multiply them like by the whole number? You know what I'm saying?
I'm not sure I'm understanding your question.
Like, okay, you know how you do it.
So does it matter if I multiply it at 34 times 56 or 3.4 times 5.6? It doesn't matter, but because I know that this was 3.4 times 5.6, I need to incorporate those two decimal places in my answer. So it does. So if I do 34 times 56, it's going to give me 1904 with a decimal place after the 4, right? Or if I do it this way with 3.4 and 5.6, it gives me the decimal place after the 19. And that's where I want the decimal places after the 19. So if you understand that concept, no, it does not matter. You just got to make sure you put your decimal in the right spot. Now it's times 10 to the what? What am I going to do here with those exponents? Add them, so it gives me 10 to the 8th, right? Now, is this number here between 1 and 10? Is that number between 1 and 10? No, so I'm going to move it to the left. I'm going to 1.904 times 10 to, I went to the left. Where's that number got to go? It's actually got to go up. Okay? And the way that I remember and remind myself that if I get stuck is I will write this number out. Okay, I will write this number out, moving this thing over to the right 8 spots, right? So I'll go 1904 followed by 6 zeros. Put my decimal place there, and then move my decimal place back in that standard number, and I'll move it back between the 1 and the 9, and I'll count that it has to go 9 spots back to the left. Does that make sense? And that's the reminder that means when I move my decimal place 1 to the left, it actually goes up with the exponent.
Don't trip.
Yes.
Are those dolphins here?
Yes.
Second thing.
That's weird.